Welcome back. Before we start our deep dive into today's topic, please take a second to hit that like button, subscribe to the channel, and turn on notifications so you never miss a technical breakdown. It really helps the channel grow. Welcome to this deep dive into Apache Rivet. In this video, we'll explore how Rivet enables TCL scripting directly within the Apache web server. Rivet is not just a module, it's a gateway to embedding logic into your HTML pages, offering a lightweight and performant solution for TCL developers. Whether you're maintaining legacy systems or building new tools, Rivet offers a unique approach to server-side scripting. Apache Rivet is an Apache module that allows you to embed TCL code directly into your HTML pages. Unlike traditional CGI scripts, Rivet processes TCL code inline, which makes it faster and more efficient. It's particularly useful in environments where TCL is already the primary scripting language, offering a seamless way to create dynamic web content. Why would you choose Apache Rivet? First, it integrates natively with Apache, offering low-latency execution. It's perfect for organizations that already rely on TCL, allowing them to extend their existing infrastructure to the web. Rivet also supports both procedural and object-oriented TCL, giving developers flexibility in how they structure their applications. Compared to traditional CGI scripts, Rivet offers better performance because it keeps the TCL interpreter alive across requests. However, it's less common than PHP or Python-based frameworks. That said, if you're in a TCL-heavy environment, Rivet can be a more efficient and resource-conscious alternative to full-stack frameworks. At its core, Apache Rivet is a module that hooks into Apache's request processing pipeline. It uses an embedded TCL interpreter to execute scripts found in .rvt files. These files can contain a mix of HTML and TCL code, and Rivet intelligently processes them based on configuration. This architecture allows for both template-based rendering and direct script execution. When a user makes a request to a Rivet-enabled Apache server, the server routes the request to Rivet. Rivet then parses the .rvt file, identifies the embedded TCL code, and executes it using the TCL interpreter. The result is then formatted into an HTTP response and sent back to the client. This entire process happens quickly and efficiently thanks to Rivet's tight integration with Apache. Setting up Apache Rivet involves a few key steps. First, ensure Apache and TCL are installed. Then, download the Rivet source, compile it as an Apache module, and configure Apache to load it. Once everything is set up, you can test it by creating a simple .rvt file with embedded TCL code and accessing it through your browser. .rvt files are the core of Rivet applications. These files can contain both HTML and TCL code, with Rivet directives used to control logic flow. For example, you can use :rivet commands to loop through data or conditionally render content. This makes it easy to separate logic from presentation without overcomplicating your codebase. Rivet provides a clean syntax for embedding logic using directives like :rivet :print or :rivet :if. These allow you to perform loops, conditionals, and even include other .rvt files. Variables defined in TCL can be used in HTML, making it easy to pass data from your backend logic to the front-end presentation layer. One of Rivet's key strengths is performance. Because the TCL interpreter is persistent across requests, there's no need to start a new process for each request like in CGI. This significantly reduces startup time and makes Rivet ideal for low-resource environments where efficiency is crucial. Rivet includes built-in support for session management through the :rivet :session command. Sessions can be stored in memory or persisted to files, and Rivet allows you to configure custom session handlers for more advanced use cases. This makes it easy to maintain user state across requests securely. Rivet integrates seamlessly with TCL's database libraries, such as TDBC. You can connect to databases like MySQL, PostgreSQL, or SQLite directly from your .rvt files. Whether you prefer raw SQL or a more ORM-like approach, Rivet gives you the flexibility to interact with your data efficiently. Security is a major concern when embedding scripts in HTML. With Rivet, it's important to sanitize user input and use built-in escaping functions to prevent injection attacks. You should also limit access to dangerous TCL commands and ensure session and cookie handling is secure. To further improve performance, Rivet supports various caching strategies. You can use Apache's mod cache for full-page caching or implement TCL-based caching for dynamic fragments. This is especially useful for content that doesn't change frequently but is requested often. Let's look at a real-world example, an internal dashboard built with Rivet. This dashboard displays real-time system metrics and runs on legacy infrastructure where TCL is the dominant language. By using Rivet, the team was able to deliver a responsive, low-latency interface without migrating to a new stack. How does Rivet compare to other TCL-based web solutions? Compared to Mod TCL, Rivet offers better performance and more features. Unlike Navi Server, Rivet is tightly integrated with Apache, making it ideal for environments that already rely on Apache. While TCL HTTPD is more standalone, Rivet excels in Apache-centric deployments. Rivet also supports advanced features like custom commands, asynchronous processing, and integration with external APIs. You can even implement template inheritance for more modular designs. These features make Rivet a surprisingly powerful tool for building complex web applications. Debugging Rivet applications involves checking Apache error logs and enabling Rivet's debug mode for verbose output. You can log TCL variables and execution flow to trace issues. As with any web development, start with simple .rvt files and gradually build complexity. When deploying Rivet applications, ensure TCL and Rivet are properly installed on your server. Configure Apache virtual hosts to route requests correctly, and set proper file permissions for your .rvt files. After deployment, monitor performance and logs to catch any issues early. While Rivet's community is smaller than mainstream web frameworks, there are still valuable resources available. The official Apache Rivet documentation is a great starting point, and the TCL community forums offer support. You can also find sample projects on GitHub and legacy system wikis with practical examples. Despite its strengths, Rivet has limitations. Its ecosystem is smaller than PHP or Python frameworks, and there are fewer third-party libraries available. Non-TCL developers may face a learning curve, and documentation for advanced topics can be sparse. These are important considerations when choosing Rivet for a project. Rivet is a great choice when you're working with existing TCL infrastructure, need low-latency performance, or are modernizing legacy systems. It's also ideal for resource-constrained environments where efficiency matters more than ecosystem size. Let's walk through a simple Rivet application. We'll create a .rvt file, embed TCL logic to generate dynamic content, and use Rivet directives for control flow. Once saved, we can test it in the browser and monitor Apache logs for any issues. Rivet is particularly useful in legacy modernization projects. If your organization relies heavily on TCL, Rivet allows you to extend those systems to the web without a full-stack migration. You can leverage existing TCL libraries and gradually transition to more modern tools as needed. To get the most out of Rivet, use persistent TCL interpreters, enable caching for static content, and minimize external API calls. You should also profile your TCL code to identify and eliminate bottlenecks. These steps can significantly improve your application's performance. template inheritance, and Rivet allows you to define base templates with placeholders and extend them with custom content. This reduces code duplication and improves maintainability. It's a powerful feature for building consistent, modular web applications. Rivet supports internationalization through TCL's MSGCat package. You can create multilingual templates and render content based on user locale. This approach is flexible and scalable, making it easy to support global audiences. Integrating external APIs in Rivet is straightforward using TCL's HTTP package. You can make API calls, parse JSON or XML responses, and display the data in your Rivet templates. Always handle errors and timeouts gracefully to ensure a smooth user experience. Monitoring and logging are essential for maintaining Rivet applications. Use Apache logs to trace requests, log TCL errors and exceptions, and monitor performance with Rivet's built-in stats. Set up alerts for critical issues to ensure your application stays healthy. While Apache Rivet is not actively developed, it's still maintained and used in niche and legacy environments. There's potential for community-driven updates, and it remains relevant for TCL ecosystems. For organizations deeply invested in TCL, Rivet continues to offer value. Compared to modern frameworks like Django or Express, Rivet is minimal and lightweight. While modern frameworks offer more features out of the box, Rivet excels in TCL-centric environments. It's a trade-off between simplicity and power, and the right choice depends on your specific needs. When developing with Rivet, follow best practices like separating logic from presentation, using Rivet directives wisely, sanitizing all user inputs, and keeping templates modular and reusable. These practices will help you build maintainable and secure applications. Integrating Rivet into DevOps pipelines involves automating deployments with CI/CD, using containerization for consistency, and monitoring logs and metrics in real time. Always have rollback strategies in place for failed updates to ensure system stability. A Rivet security checklist includes sanitizing all inputs, escaping output to prevent XSS, securing session handling, and limiting access to dangerous TCL commands. These steps are crucial for protecting your applications from common web vulnerabilities. In one enterprise case study, Rivet was used to build internal tools and dashboards that integrated with legacy TCL systems. It provided low-latency web interfaces and significantly reduced migration costs. This made it a cost-effective solution for extending legacy infrastructure. To summarize, Apache Rivet is a powerful tool for bridging TCL and Apache. It's ideal for TCL-heavy environments, offers excellent performance, and is great for legacy modernization projects. While it may not be as popular as mainstream frameworks, it remains a valuable option for the right use cases. Thanks for watching this deep dive into Apache Rivet. If you found this tutorial helpful, please give it a like and subscribe for more technical content. Drop a comment below with your questions or thoughts, and check the description for additional resources. See you in the next one. And that wraps up our explanation. If you found this useful, please hit the like button and share it with a fellow developer. Don't forget to subscribe for more technical tutorials. Thanks for watching, and I'll see you in the next one.